Okay. Okay. So on a large country estate in Scotland, the population of grouse is 10,000. The population increases naturally every year by 10%. During hunting season each year, 2,000 grouse are shot on the estate. Write down a difference equation Pn of the grouse population after n years. Okay. So what we're thinking here is room for. So what we're taking here is, so let x be the population in a given year, and you're going to multiply x by 1.1 because you're going to increase the population by 10%. But then you're also going to take away what? 2,000, aren't you? So then we got to write this formula as a difference equation. So what we say is P of n plus 1 equals 1.1 Pn minus 2,000. Is that right? All good? Okay. Does everybody understand where I got that from? You sure? Okay, done. Ka-ching. Solve this difference equation given that P0 is 10,000. So what we're going to do is first we're going to do P1. P1 is what, guys? 1.1 times, what's P0? What? 10,000, yeah? So 1.1 times 10,000, and your first instinct is to multiply that out and just get the answer, isn't it? But that's not the technique. The technique is don't multiply anything and see if there's a general pattern. So what would P2 be? 1.1 P1 take away. How much? Take away 2,000, isn't it? All right. So what we're going to do here is the following. I'm going to move that minus 2,000 to the very end. And what am I going to replace P1 with? I'm going to replace it with the previous line, haven't I? So I'm going to replace P1 with the previous line, which is 1.1. 1.1 times 10,000 minus 2,000. Okay, lock it in there, yeah? What do we get for P2 then? 1.1 squared times 10,000, yeah? Minus 2,000 times 1.1, is it? Minus 2,000. You agreed with that? See the way the first one had two terms? See the way P1 had one part, and then it had a second part, didn't it? So P1 had two terms. How many terms does P2 have? 1, 2, 3. How many terms do you think P3 is going to have? It's going to have 4 terms. And I'll show you now what it's going to turn into. You start getting used to these after a while, and you sort of see a general pattern amongst them all. What do you think P3 is going to be? Instead of 1.1 squared, it's going to be, anybody? 1.1 cubed. Okay? Now, so that's 1.1 to the power 1, isn't it? So there was a T1 and a T2. But this time there will be also there's going to be a T3 as well. So it's going to be minus 2,000 by 1.1 to the power of 2. And what about, and then the other one's going to be minus 2,000 times 1.1 to the power of 1, and then finally minus 2,000. Agreed? Now, what do you think of the general equation? Let's look at this yellow part. What can we say about the general equation for here? Anybody know? 1.1 to the power of n times 10, times P0 or 10,000. Okay. Now, next part. What do we reckon about this here? Geometric sequence. T1, T2, T3, isn't it? It's going to go all the way up to Tn, isn't it? So that means we can use a Sn formula, yeah? Now what you notice, T2 is the power of 1, T3 is to the power of 2. So it's always one less, isn't it? So let's start off with our A value. What do you think our A value is? Minus 2000. Our R value, 1.1. Okay, and then we get our Sn value, yeah? So what's Sn? A into 1 minus Rn all over 1 minus R, right? And then what? So what's A again? Okay, times 1, take away 1.1 to the power of, and all over what goes? 1 take away 1.1. Now, somebody really quickly in the calculator just do this for me. Do minus 2000 divided by 1 take away 1.1. I think it's going to turn out to be like 20 grand or something like that. 20,000? Well, yeah, whatever works. So 20,000, yeah? Now I'm going to multiply in that 20,000. What do I get here? Minus 20,000, yeah? And what else? Plus 20,000. Well, yeah, times 1.1m. Market scheme's wrong. Yeah, I'm disagreeing with that. Yeah, I'm coming out as positive. They're coming out as whoa, whoa, whoa. What? I'm going to reverse the step. Sorry, guys, we're just disagreeing with the margin scheme. So they were both negative. The top and the bottom was negative, wasn't it? So that made it positive. So I'm happy with that 20,000. Anybody else get that as well? Where you disagreed with the marketing scheme? Yeah. So we're all in agreement, aren't we? So it's going to be plus 20,000. Oh, wait. It's all good. I'm actually in agreement with the marketing scheme, never mind. I'm actually agreeing with it. So multiply 20,000 by 1.1 to the power of, and so the market scheme is actually correct. Excuse me. Excuse my blasphemy. What? Yeah. 20,000. Now, how do you compare this one and this one together? This one here and this one here. Just take it away, isn't it? So who got 10,000, 1.1 to the power of n? All right? That's your general formula. Now, what's it going to ask me to do now? Get year 4 and year 5. So replace it to the power of 4 and use your calculator. What you get? I'll tell you now in a second. Just put it to the power of 4 and you should get 5,359. When you do it to the power of 5, you should get 3,895. What are you noticing about the population going from year 4 to year 5? It's on its way down, so they're going to become extinct soon, aren't they? They're going to be gone. Now, after how many years will they disappear? Anyone know how to do that? Put it equal to 0, solve it, and any extra years will, because you're decreasing every extra year, anything above your answer, and they'll be extinct. Does that make sense? So bring that to the other side, and I'm just going to get 10,000, 1.1 to the power of, it's the power of n, isn't it? Equals 20,000. Divide 20,000 by 10,000. We get 2, don't we? ln both sides. And we're going to get ln 1.1 equals ln 2. What's going to happen to that ln 1.1? Bring it underneath, yeah? And what happens to the answer then? What do you think we get? 7.272. So after 8 years, after 7 years, there's still a population. So anything bigger than that, and no extinct. Do you get what I'm saying? So year 8. Year 8 is the next whole number available. Is that right? Now, what's the last question? If you're to advise the owner of the estate, what's the maximum number of grouse she should allow to be shot every year on her estate? Okay, we're going to reverse back time. And we're going to go all the way back to my SN calculation from earlier, or what's left of it. It's pretty shattered looking, isn't it? It's pretty shattered looking. It hasn't even returned yet. So that's the formula, isn't it? Now, what we're going to do is, the only thing we're doing differently is we're no longer saying A is minus 2,000, are we? What are we going to say A is? Pick a letter. I'm going to pick K. I'm shooting K gross a year. Does that make sense? If I choose A as K, yeah, I think that automatically means K is going to be negative, because I haven't accounted for the fact that it's decreasing the population, not increasing. So I'll put it down as minus K, if that's all right. Same way I wrote down minus 2,000. Is that right? So we're going to put in our formula again. So what's the formula this time? A gets replaced with? So that was 2,000, wasn't it? And now it's that. And what did we say earlier? It's 1 take away. And what's 1 take away 1.1? Minus 0.1. What's minus K divided by minus 0.1? Plus 10K. And we're back. So we all agreed with 10K, was it? 10K? Okay. And it's 10K, 1 take away 1.1 to the power of n. Agreed? Okay. Now, here's what's going to happen. Huh? I think I counted it. It multiplies by the 1 and then the 1.1 n. Yeah, sorry. Now, here we go. Okay, multiply 10K and what do I get? 10K. I also get minus 10K 1.1 to the power of n. And everybody sees the 10,000s? 1.1 to the power of n. Everybody see that? Now, the 10K remains constant. It's a positive number. So I think we're all right with that. But what we have to check is that this doesn't become negative, right? Because if that's negative, what happens? You're losing, it's a negative number to the power of 1.1 n. And what happens to 1.1 n every year? What happens to this number every single year? Bigger, 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 and eventually your population dies out. So what we've got to guarantee is that this yellow number is not negative. So how do we do that? Yellow number equals 0. 10K is 10,000. K equals 1,000. 1,000 grouse you're allowed to kill. If you kill any more, what happens? Goes extinct.